Moving on to the second problem set, we are looking at an excavation for a trench. The Plan 100 is a basement foundation, as we just looked at, but we are going to make some changes in order to be able to calculate a sample trench excavation. You will always need to use your plans and your specs provided, but make sure that you also read any additional bullet points that I have provided to help you with the answers that you need to obtain. So we're changing our basement to a slab on grade. We're going to have a workspace that is 1'6" beyond our 8 by 16 footer dimensions. We'll have an excavation that will go to the bottom of the 8 by 16 footers, which means for our front wall that is 12 by 24, we're going to have to excavate the remainder of those 4 inches by hand. Our angle of repose is 35 degrees. No existing grade is provided, therefore we'll have to use finished grade to obtain our dimensions. We have a swell factor of 15% and a shrinkage factor of 5% or 0.85. So a note about footers. So looking at footers. It does not matter if it's written 8 by 16 or 16 by 8. Both of those mean that we have an 8-inch tall and a 16-inch wide footer. It's not length and height, height and length. The smaller number will be your height, the larger number will be your width. Unless it's a special condition where they will specify that you have a 16-inch tall and 8-inch wide footer, all of your smaller dimensions will be the height, the wider dimension will be your width. So when we're looking at a visual of our trench, we know how to take section cuts. So we're going to cut it side to side and we're going to look backwards. If we do that, this is essentially what we would see once we have our excavation in place. It goes down to the bottom of the 8 by 16 footers and it goes all the way around. If we want to put some numbers to that, we will see that we've got our 8 by 16 footer. Our excavation height is based upon the fact that we go down to the bottom of our 8 by 16 footer, but it will not go past this 8 inches below top of wall. We're not going to excavate the entire foundation wall, nor are we going to bring our backfill up all the way to the top of the wall. It is going to be 8 inches below. This is a dimension that can also be found on the wall section. We'll use our numbers, our 16-inch footer, our workspace, and our unknown to calculate our average width. Additionally, if we want to look at a cut from front to back and looking to the side, we will have a view that looks like this. So for our front foundation wall, again, we will excavate this portion by hand so that we will have a consistent trench all the way around our foundation. Again, throwing some numbers in there. The other thing that will change is the fact that we will have less workspace around our 12 by 24 inch footer. We're going to keep the excavation trench the same all the way around, which means that we'll have 8 inches of additional footer in the front. Split that in half. That means we have 4 inches left of workspace then around the back and the sides. But it will maintain our numbers the same to do it this way. So if we are looking at our sample problem, the first thing we need to calculate is our depth of excavation. We'll need a couple things. We'll need to know, the wall height. We can find that on the plans as 8 feet. We need to know our footer height. Again, it's all based off of the 8 by 16 inch footer, so we'll use the 8-inch high wall. We also need to know the top of wall to grade dimension. I pointed that out on the plans. You can find it on the wall section. So that is the 8-inch dimension. If I ever refer to top of wall in the future, I'll just say TOW. I'll say top of wall, but I'll write TOW so that you will know what I am referring to. So our excavation height then we take our foundation wall plus our footer height, and we get 8'8". So wall height, footer height, 8'8". But again, we're not going all the way to the top of wall, so we have to subtract out that 8 inches that was from top of wall to grade. So our excavation height actually comes back to 8 feet, just like the wall height. But do not make the assumption that every foundation will have your excavation height the same as the wall height. It just so happens that in this sample problem, that is the case. That will not always be the case. We'll need to know that for number 6 when we are calculating our average width. So for average width, we need a couple of things. We need to know what our footer width is. And again, all of them are going to be based off of the 16-inch or 1.33 feet, if you want to write it as that. We also need to know what our workspace is. That was given to you in those bullet points. 1.5 feet or 1 foot 6 inches. The last one is our unknown. H over tan or tangent of your angle. Height, that is going to be your height of excavation, not your height of wall. So again, we need to make sure that we're always paying attention. It is the one we just calculated. That is what will be our height. Tangent of your angle, that is your angle of repose. So calculating our unknown, we can see that we have 8 feet over tangent of 35 degrees. That was given to you. We have 11.4252 feet. So our average width calculation then, 1.33 feet plus 2 times 1.5 feet. We need 2. Each side of the footer has workspace, or each side of the foundation wall, so we need to make sure we multiply that by 2, plus 11.4252 feet. 15.7585, which I've rounded to 15.8 feet, is our average width. Number 7, we're calculating the volume of soil to be excavated. One of the easiest ones we're looking at, volume, length times width times height. Our length is our center line, which we calculated in number 4. Our width is our average width that we just calculated in number 6. And our height is our excavation height, which we also have previously calculated in number 5. So it's just multiplying through volume, length, 121.667 feet, times width of 15.7585 feet, times our 8-foot excavation height, not wall height. Take a moment to make a note about decimals. Even though we round our final answers for our average width and our center line, we need to write out the unrounded numbers when we are doing future calculations. So whether you're putting them in your calculator or you're writing them out, make sure you include those additional decimals so we get the most accurate number. 15,338.2902 cubic feet. And we need to convert that to cubic yards by dividing by 27. Remember, 1 yard is 3 feet. So cubing feet, we have to cube the yards as well. So we have 27 cubic feet per cubic yard. Answer then is 568.0848. I've rounded to 568 cubic yards. So number 8 is now the longest of the calculations that you have to do. Not that difficult, but just lots of parts and pieces. We need to look at the volume of the foundation system below grade. So it's both the footer and the foundation wall. So what we're talking about is we have our trench excavation. We've got our foundation wall that we've poured. Once that has cured, we're ready to backfill. We have to fill in all of this space with dirt. And to know how to calculate that, we first need to figure out what is the volume of the foundation wall and footer. In our Plan 100, the front wall is different size than the back and side, so we have to keep that separate. So if we're looking at our walls first, our front wall, again, volume, length, width, and height. Length, we need to use our 35-foot 4-inch center line. Length, our width is our 12-inch thick wall. Our height is the 8-foot wall height, but we need to subtract out the 8 inches that is the top of wall to grade. We are not going to backfill all the way back up to the top of the wall, so we only have 7 foot 4 inches of wall that is actually below grade, and that's what we'll use in our calculations. The back and sides, we have 86 foot 4 inches. We calculated that at the end of problem 4. We have 8-inch thick wall, and again, same as up here, 7 foot 4 is that actual dimension. So if we have our front plus the back and sides, multiply those out, add them together, we will end up with 681.185 cubic feet. We're going to leave that there for a moment and calculate the footers. So again, front is different than the back and sides. It's still the center line length. Our width is the 24-inch footer width. Our height, even though it is a 12-inch tall footer, remember we aren't going below that 8 inches for the back and sides, which means we don't have to worry about that portion of the foundation system below grade. So we only need to worry about the 8 inches of the height. Our back and sides, 86.4. We have 16 inches is the thickness and 8 inches is the height. So our front plus back and sides for our footers is 123.852 cubic feet. So our total is our wall 681.185 plus our 123.852 cubic feet. So divide that by 27 cubic feet per cubic yard, and we get 29.8162, and I just rounded to 29.8 cubic yards. So again, just basic volume calculations, but it's making sure you pull the correct numbers when you're doing those calculations. The last three are trying to help us figure out volume for what we're going to be hauling away, as well as backfill. So we first need to calculate what that backfill is. And it is simply our excavation minus our foundation system. So our answer from number 7 minus what we just calculated in number 8. We have the 568.0848 minus 29.8162, 538.2686. 538 roughly cubic yards. So 10 is looking at how much we're going to haul away from the job site once we've excavated. We need to apply our swell factor to our excavation, which we calculated again in number 7. So it's our 568.0848 plus 1, multiply by 1 plus our swell factor of 0.15 or 15%. As we pull it out of the ground, it's going to swell up, so that's why it's called a swell factor. 653.2975, so roughly 653 cubic yards. This is what we are going to call as our loose cubic yards. If you wanted to use loose cubic yards as your units, that is also correct. If you leave it in cubic yards, that's fine. Generally, we do not specify between bank, cubic, and compacted. Bank, compacted, and loose cubic yards. We just talk about it in cubic yards, but if you need to write the L, the B, or the C to figure it out and keep it straight in your mind, that is perfectly acceptable. The last one then is looking at how much we're bringing back for backfill. So we need to look at our answer here from number 9, the 538.2686. We divide that by our shrinkage factor, the 0.85 or 85%, and then we multiply that answer by 1 plus our swell factor. Remember, we have to do 2 steps for backfill, but make sure you divide first and then multiply. 728.2457, 728 cubic yards or loose cubic yards. So as we can see, if we're going to pull out our excavation materials, it's roughly 653 cubic yards. But what we need to bring back is actually more than that. Even though we're reducing the volume by putting in a foundation system in there, we have to bring back more because of what we are compacting and putting in back in its place. So if you're able to keep this amount back on the job site, then you would only need to bring in the difference. But if it's contaminated or required a different type of backfill, you have to haul all this way and bring back even more. So that concludes the trench excavation sample problem.